Okay, so let us start the lesson. So we talked about exponents and powers yesterday. I want to continue that today. So if you remember, let me just refresh your memory and give some to some people. So we started with this idea that if I have a power of this form, a can be any number that you like. Yes. But n, we restricted ourselves first to this list, 1, 2, 3, etc. And then we define this if n is a natural number. By the way, I told you that this is a symbol in mathematics. You say little n, this symbol means belongs to, and then we put this with an extra line to say that this is the set of natural numbers. So when I say natural numbers, I mean the set consisting of these numbers, 1, 2, 3, 4, etc. And then this is the common thing that you have to respect these rules. You have to put them between curly brackets. Okay, so that is the set of natural numbers. And I am separating them, of course, this is a comma. Might be my handwriting is not good, but this you have to separate them with commas and then the 3 dots. So if n belongs to n, then we defined it in that way. It means that I start multiplying the base by itself. How many times? N times. Yes. That is the meaning of this power. I didn't mention this in this form, but that is what I told you yesterday. And it doesn't matter what is that number. For example, I can also talk about a square root of 2, for example, to power 4. What does this mean? It means that I take the square root of 2 and multiply it by itself 4 times, yes? Yes, sir. But this is now easy to calculate. Hopefully, what is the square root of 2 times the square root of 2? Is 2, and this is also 2, but 2 times 2 is 4. For example, this is 4. So you see that again, I am not very sensitive to which type of number the base is, but here I am sensitive that what I choose should come from the set of natural numbers. And I told you, usually mathematicians, when they start learning something, they ask themselves, how can I generalize the idea? So then it means that we have to try to extend this exponent to cover all sorts of numbers if possible. The first thing that comes to mind is to add 0 to my list. Yes, and we had the convention for it, and I try to convince you that this is indeed a good convention. So a to the power of 0 is by definition equal to 1. One exception is that a is 0. So a shouldn't be 0. And then I told you that there are 2 conventions. Some people say 0 to power 0 is 1. But we checked it with GeoGebra, it told us 1, but the calculator, for example, in iPhone or something, showed that it's undefined. But let me try to have the convention, it is undefined. Okay? But still the problem is not finished, because we can have integers with negative values. Then what happens if they turn out to be on the exponent? So in other words, what happens if I want to answer this question, 2 to the power of minus 3? Minus 3 is not in my list, so I want to teach you a new way of doing that. And I told you this before. So I told you that if a is not equal to 0, then a to power minus n is indeed defined. But let me just take it again. Semicolon equals to means that by definition is 1 over a to power n. So when I ask you to remember this, that's an important formula. This is the definition. So I'm just reviewing things, recapping things. So here, if I ask you calculate 2 to the power of minus 3, you realize that this definition, let me also put a semicolon here. This is only for the case that n is a natural number. So here, if I ask you to calculate, you are not able to calculate it using this because it doesn't make sense at all. Multiplying 2 by itself negative 3 times, which doesn't make sense. So this means that as soon as I see a negative power, I need to remind myself of this new definition, not the old one. The old one will not work here. So what I do, I would write it's 1 over 2, But instead of writing negative 3, I write positive 3. But we already know what is 2 to power 3. It means 2 times 2 times 2. It makes sense now. It means multiplying 2 by itself 3 number of times, sensible. Then it becomes 1 over 8. So that is something that you also learned yesterday. So remember, now if I ask you what is the list that I have, you will tell me that the list that you have is this one. That is the set of integers. So now I have all these numbers, -4, -3, -2, any number which is an integer, the whole number, but positive, negative, or 0. Yes? So now if you are asked about exponents which are coming from this set, you don't have any problems. In principle, you should be able to calculate. But of course, there are many numbers missing yet. You see there are no fraction numbers here, but we know that, for example, 3 over 4 is also a number, but it is missing in this list. We also have a square root of 2 missing here, pi numbers. We will talk a little bit about them later. But today, my goal is not to expand this. My goal is to give you some rules that are extremely important. And you will find always them in the formula sheet, but I really recommend you, after understanding them, try to send them your number, okay? One rule is this. If I have a power, I have another power, but the point is that the bases should be the same. And if I insist you to multiply them, of course you can do them without any rules. For example, if I ask you, can you calculate 2 to the power of 3 multiplied by 2 to the power of 2, definitely you will be able to do this. You will tell me 2 to power 3 is 8, 2 to power 2 is 4, and then you multiply 8 by 4 and you get 32. Remember, this is not my goal. My goal is not to calculate this. My goal is to write this in a slightly different way. What I want to show you is that you can, if you want to, you can write the same base, but add the exponents. Yes? So be careful. I haven't calculated anything. For example, in this case, if I ask you 2 to the power of 3, 2 to the power of 4, 2 to the power of 2, how much is this number? You answer 32. But if I ask you, can you write it in a different way? You would say, according to that rule, I write 2 and I add the exponents. And the exponents become 5. So you see, this is one rule that enables me to write the product of two powers with the same base as one single power. So then I want you to remember this. If I have the first of all, why this is true, by the way? This is very simple. When I say 2 to power 3, it means that I am multiplying 2 by itself 3 times. And then 2 to power 2 means multiplying 2 by itself 2 times. So if you look at the whole package, it seems that I am multiplying 2 by itself how many times? 5 times. And that means 2 to power 5. So it's actually immediately understandable. Yes? So, and I want you to send it to your memory right now. If I want to read it in English words. If you are supposed to multiply two powers with the same base, you can write the same base and add the exponents. Okay, so this is important because it is not important to just memorize the formula. You should be able, by looking at these symbols, read this English or Swedish or whatever sentence you want. So you should be able to translate this formula into the form in the English words or in the language form. So this tells me that if I am supposed to multiply two powers with the same base, I can write the same base and add the exponents. That's the rule. But by the way, it was very trivial here because I chose them intentionally to be of this list. Then the question is this formula also true if m and n could be negative? That is important. The answer to this is yes, but it is not that trivial. Let us see why. How should we do that? If I ask you 2 to power minus 3 times 2 to power minus 2, can I still use the same power rule? The answer is yes, but I want you to understand the argument why this is true is not as the previous one. In the previous one, I told you 2 to power 3 means 2 multiplied by itself 3 times. 2 to power 2 means 2 multiplied by itself 2 times. So in the whole, I have 2 multiplied by itself 5 times. Very simple. But when I say 2 power minus 3, I cannot say multiply 2 by itself negative 3 times. So the idea changes. But the good news is that even though the definition is different, but the rule is the same. So that is good. Okay? So you don't need to remember different rules for different exponents. Whatever the exponent is, it follows the same rule. But I want you to at least feel that the argument behind the natural powers is not the same as the argument behind negative powers. Yes, we have to redo it again. Okay, how should I redo it and convince myself this is the case? I want to convince myself that for the negative powers I can use the same rule, writing the same base and adding the exponents. Okay, but instead of minus 3 plus minus 2, people can write minus 5. So we want to answer this question mark. Is it also valid if I choose negative powers? We will see yes, this is valid. Why? Because 2 to the power of minus 3 times 2 to the power minus 2 can be written as 1 over 2 to the power 3. Because if someone asks you what is the meaning of 2 to the power minus 3, I just defined it here for you. So instead of this one, I write that. But instead of this one, I write this. Yes? But we learned that if I want to multiply this fraction by that fraction, I have to multiply the numerators. I have to multiply the denominators. Yes? For the numerator, I don't have any problem, so that's 1. But for the denominator, I can immediately use the rule because now they are positive powers. So then it becomes 2 to the power of what? 3 plus 2, which is right. 2 to the power 5. But 2 to the 1 over 2 to the power 5 is the same number as 2 to the power of minus 5. Now if you do not look in the middle, what happened? This becomes equal to that. So again, that is true. But you see that this is different, completely different from what I said. Okay, so that is rule number 1. Yes? Okay, so let me give you some questions here. For example, if I write 2 to the power of 3 multiplied 2 to the power of minus 5 multiplied by 2 to the power of 7, okay, what can I write here? Can I use this rule? Yes, because I am multiplying powers with the same bases. That is important. So this rule is applicable. I write the same base, and then in my head or in my paper, I add them up. Yes? And then 3 plus minus 5 is minus 2. Minus 2 plus 5 is plus 7 is 5. So it becomes 2 to the power 5. Okay. Sometimes you see for Grundschooler might be they want you to find the answer, but here we don't care about the answer that much. We care about understanding that this number in mathematics, whatever it is equal to this number. Of course, if I ask you what the number is at the end, you have to multiply 2 by itself 5 times and the answer becomes 32. Usually they don't ask in this way. They ask you in this way. Write the following items as one single power. If they ask you this, and if you answer 32, even though 32 is the correct answer, but I will not accept it from you because you are not following what is wanted in the problem. The problem doesn't ask you about what is the value of this expression. It is asking you to write this expression, which is a combination of 3 powers, as one single power. Okay? So that is the idea. Any questions? Okay. Now, let me ask you one question. Let me see how do you understand the problem. because based on my experience, this is a little bit harder problem for some students. So you see, if I ask you 2 to, let me write the example like this. If 2 to power x is 4, what is 2 to power x plus 2?
2 to the power of 4.
No.
Wait. 2 to the power of 2.
No, tell me, how do you calculate that? So if someone tells you that I have a number in mind, which I call it x because it is unknown, but I give you one piece of information. I tell you the number that I have chosen has this property that 2 to the x is 4. Now I am asking you, for the same x in my head, 2 to power x plus 2 is what? Yes?
16.
Abdullah, yes?
2 to the power of 4, and which is 16.
16. How did you find that? How did you find it is 2 to power 4?
Because x is 2 to the power
Okay. Yes? So you told yourself 2 to power x is 4, then
x is 2.
x is 2. Be careful about this conclusion. X is 2. Everyone agrees?
Yes.
Because 2 to power x is 4, so x is 2. And then the question mark is equal to 2 to power x plus 2.
That's 4.
But you already found x is 2. Yes? And then 2 plus 2 has a better name. It is 4. And 2 to power 4 is 2 times 2 times 2 times 2, which is 6. Yes? Now, this is the reason. This was a very simple question. The reason that I brought this up, because I want to change the question to a slightly different one. Okay? So my question for you is, I want to change this 4 to 5. And ask you the question again. Okay? So the question is this. If 2 to power x is equal to 5, what is the same question? Okay? So the reason that I bring this very simple example up, because this is a very good tool in my hand to show you that you have to respect the rules. This is why I am bringing this question. Let me repeat this. You might ask yourself why I want to read extra rules. Because instead of doing this, I can calculate them separately and multiply them instead of trying to remember new rules. Okay? Yes. If it is possible, I agree with you. It is if you can do it, but sometimes even it becomes harder. But sometimes it becomes impossible. You see, here you were able to solve the problem without even knowing any rules, extra rules. And the answer is correct. If you write this in the exam, you get the total points. Not wrong, okay? But you see that I changed the question slightly. If I say what is the difference between this question and that question, the only difference is that 4 has changed to 5. So, but I hope that you understand this problem is not we are not able to solve it in that way again. Because you might ask yourself, what is x? Here, instantly you answered me, it is 2. But here, what is that number? You might ask, first of all, how do we know such a number exists? Yes? But it exists, you need to trust me on that. You will study it in Math 2C. That is a logarithm, okay? But forget about the logarithm. Even if I know logarithm, I will not use logarithm to solve it. Because this one that I want to teach you is more efficient. Yes?
Divide 2 to the power of x plus 2 by 2x.
No, you cannot divide. That is a common mistake among students. I don't know how. I am asking about something. You cannot change what I am asking and say. So you see, if you divide something, I have asked you about this, but you are answering something else to me. I don't buy it, yes? I want the answer to what I am asking. If you divide this by whatever you said, you are changing my question. You understand what I mean? Is that clear for everyone? Because this is a very common mistake students usually do. They start getting rid of it by simplification. Be careful. If two quantities are equal, then what you say is acceptable for me. You see, I have the same amount of money as you have. If I divide my money by 2 and your money by 2, again we have these numbers are the same. But if I have some money in my pocket, you cannot say, okay, let us take it and divide it by 2. Okay, then what? If two quantities are equal, then yes, A divided by 2 and B divided by 2 are equal. A to power 2, B to power 2 are equal. Yes, I buy them. But here I haven't give you equality. I am asking you calculate this number. You cannot just divide that number. Yes? This is something in common. But how can we answer this question? Extremely simple, but I want you to use this. And then by experience, I know that students are very good. If I give this side to students, they don't have problems to write this side. But be careful, when you see equality, it goes in both directions. And I just warn you, harder questions are the other way around questions. That this part is given, you have to do it in that way. Yes?
2 to the power x into 2 to the power of 2.
What?
2 to the power of x.
Yes. So the question mark here, so you see the question mark here, which is 2 to power x plus 2, yes, can be decomposed as 2 to power x multiplied by 2 to power 2. This is today's lesson. Everyone agrees with that. But in all my examples so far, I have given you this part and you wrote that part. Because you say that I am multiplying two powers, the bases are the same, so I write the same base and I add the exponents. Most of the time, this is what we need. But sometimes, like this harder problem, you need to be able to change in the other direction, opposite direction. First of all, tell me, everyone agrees with what I have written here? Yes or no? Yes, okay. And then do you agree the problem is solved? Because I don't care about x. What I care about the whole combination. And the whole combination is given to be 5. So I just write 5 instead of this,
20.
multiplied by 4. The answer is 20. I was able to answer this question. If at this point you ask me, Babak, do you know x? I would say no. And I didn't need to know x. Yes? I didn't need to know x. X, you will see, it becomes the logarithm of 5 to the base 2. But that is actually even not good feeling. So what I'm saying is that this question, I will call it level 1 question, but I will call this level 2 question. Could I use this method for this problem as well? Could I? Yes. 2 to the power of x plus 2 is again 2 to power x times 2 to power 2. But in this problem, 2 to power x is how much? So this is 4. But how much is this? The answer is, and that's the same answer. So for this one, we have two alternatives. But for this one, we have only one single way. So what I'm saying is, try to respect the rules. The people who want to progress in learning mathematics are only those students who are respecting and trying to learn the rules. Yes? And then use them effectively. Is that clear? Yes?
Can you explain what you did in the second question?
In the second method, I actually wrote this and I want to ask you, okay, let me think in that way. If I give you 2 to power 2 times 2 to power 7, can you write something in front of this for me? Yes, what is this according to this rule? 9. How did you understand? You write 2 and you add 7, 2 and 7. So it becomes 2 to power 9. But now if I write 2 to power 9 is equal to 2 power 3 times 2 to power 6. Do you buy it from me? Yes? Do you agree this is also true? Do you agree this one is also true? Okay, so you see that going from this direction to that direction is one way, If I give you this, there is only one way to write it down. But if I give you this, depending on the situation, you can write this, you can write this, you can write plenty of things, yes? In this case, I did the same thing. Instead of 2 to power x plus 2, I wrote 2 to power x times 2 to power 2. Why this is good? Because the information given in the problem is giving me 2 to the x is 5. And then I can take this away and then put 5. And then 2 to power 2 is 4, and then multiply, get 20. Did you understand or not? Okay, so respect the rules. The first rule, please memorize that, okay? In words, if you want to multiply two powers with the same bases, if you want, you can write the same base and add the exponents. Okay, now let us see what is left for us. I think that there are some fun questions. It doesn't. I think it doesn't hurt if we solve them. Of course, I haven't seen them in the book, but let me just solve them for you. Okay. So, example. I am giving you more examples to be able to respect that rule a little bit more. Okay. So, write this expression 6 times 2 to power 8 plus 5 times 2 to power 9, and then 6 times 2 power 7, and then finally minus 24 times 2 to power 5 as a single power. You see, I haven't asked you how much this number is.
Minus or plus 24?
The last one minus 24.
So roll all the numbers up and then
Okay. Before giving you this question to solve, I want to try to train you a little bit for that. So, first of all, do you agree with this, what I'm writing on the board? If yes, tell me why. Because this is, if you understand this, then you will have an easier time there. So, 3 to power 4 plus 3 to power 4. Okay, let me ask you a question. If I ask you, so if you let me close the door. Because I have seen the students, they are mixing things up. Are there any rules for 3 to power 4 plus 3 to power 4? If so, I want you to respect. No, 3 to power 4 times 3 to power 4, we have a rule for it. What can I write?
3 to power 8.
3 to power 8. Okay?
The other one is 3 to power, no, 6 to power.
No, so that's what I'm saying. Be careful. Because this rule works for product, for multiplication, don't take it, if you want to be good in math, don't take this for granted. Because it was working for multiplication, it also works for addition. No. If you want to follow the rules, mathematics is unforgivable. So it means that you have to have exact scenario to be able to follow it, to use the rules. Okay? So I have a very small difference, but this might be a huge difference. But if I insist, but let me ask you something. How many of you agree that instead of this, let me ask questions one by one. If I ask you how much is this, you should be able to do that. How much, or evaluate this number. How do you do that? Yes, you multiply this by 3 by itself 4 times. If you do that, it becomes 81. This one is also 81. You add them, it becomes 162. End of the story. So if I ask you how much is this number, 162. I'm not asking this one. I am asking, how do you think this is true? Is it true?
Yes.
Yes?
Yes.
Because I have something, I am adding the same thing to it. If I have one single pen, I borrow another pen. I have how many pens I have? I have 2 pens, yes? So I have 3 to power 4 as a mathematical object. I have another of the same object. So how many of those objects I have? 2 of them. So everyone agrees? So this is interesting because now addition turns into multiplication. By the way, this is not very strange because if I ask you 5 plus 5 plus 5 plus 5 4 times, what can you write? You can write 4 times 5. Yes? So that's the same story. Okay, but how many of you agree with this one?
96, 4096.
Yes. One way is to calculate the left-hand side. It is 81, 81, 81. If you add them, 81, 81, 81, 243. And if I ask you to calculate this, 3 times, 3 times, 3 times, 3, 5 times, it is again 243. That's not wrong. That's correct. Done. But you can see it in seconds without calculating, even if this number is so big. I will tell you now. But can you just motivate why you should expect? Why do you expect such a thing happens? Yes?
Because you're essentially multiplying it by 3. So you're
Exactly. So let me show. So this becomes the left hand side is 3 times 3 to power 4. And then what? And then I'm using this rule. Yes? Because now what is the power when it is not written? 1. And then I add them, it becomes 1 plus 4, 5. Yes? So it is extremely important to understand this method because this seems a little bit strange. I am adding 3 to power 4 3 times and then suddenly it becomes 3 to power 5. Yes?
Could you use another example to further explain it?
Yes, we can do that. For example, I have 5 to the power of x plus, by the way, let me write it in that way. 4 to power 5 to the power, let me write it m and m. Okay?
Yes.
Do you agree that I can write it 5 to the power of n plus 1? These kind of things in higher school mathematics you need to learn good. Because the powers are actually from previous studies. But you should be able to understand this is correct immediately. Is it correct or not? This one, here I have 5 to power n. Here I have 4 more of them. Yes, here I have 1 5 to the m. How many more I have here? 4 of them. So in total, how many 5 to the m's I have?
6.
No?
No, wait, sorry. 5.
5. So this becomes 5 of them. Yes? But 5 times 5 to the m becomes 5 to the power of 1 plus m. But there is no difference between 1 plus m and m plus 1. So we are done. Is that understandable?
Yes.
So these kind of calculations, you see, these questions are at harder levels. Because they are not asking you to calculate anything. I even don't know how to calculate because I don't have m. Yes? I am telling whatever m is, the left hand side is equal to the right hand side, regardless of the value that you choose for m. It is a little bit higher mathematics, and you have to focus on this way of thinking. Okay, now that you have these things, let us try to understand that one. You don't have any calculators, calculator is not allowed, and you want to actually to write this as a single power. Then of course I will describe how we can use GeoGebra to do that. But let us see how this will work. Do you have any idea what to do? It's a little bit tricky, I agree. Okay, let me try to guide you a little bit. Yeah, I don't know. You have to be a little bit creative. But after this, hopefully you get some experience. I can give you one more, even harder. Hopefully you can solve that one for me. So if I want to solve that one, I want to use the same idea. How do I do that? So let me tell you something. So this question, let me write this and then probably you understand it yourself. Here, I write it as 6 to 2 to the 8. I do not change anything. But first of all, tell me, can I do this instead of the second one? I write 10 2 to power 8. First tell me, do you agree with what I have written? I copied and pasted the first part. But instead of the second term, I am claiming that I can write this. Is it true or false? Why? Because 2 to power 9 in my head is 2 times 2 to power 8. These 2 that I borrowed from this, I multiplied by this 5, it becomes 10. Agree? Yes. Let us go to the next one. Can I write the second one as 3 2 to power 8?
Yes.
Yes, but this time I broke 6 into 2 parts. I borrowed a 2 from here and absorbed it into that. Yes or no?
Yes.
Okay. 24 in my head is immediately clear. It is 3 times 8. But 8 is 2 to power 3. I absorb it here. So this becomes minus 3, 2 to power what? 8. Do you agree?
Yes.
Now I am done because everything is written in terms of 2 to the power of 8. 2 to power 8 is a mathematical creature, yes? I have 6 of them. I get 10 of them more. How much do I have of them so far? 16 of them.
Yeah.
3 of them more,
19.
19 of them. But again, I give up 3 of them. How many is left?
16.
16 of them. So this number is 16 of them.
16 to power.
Yes?
Yes.
And then the point is that, first of all, instead of writing 1, 2, 3, 4 terms, I am working with one single term. This is an art, I would say. Art of simplification in mathematics. Yes? But still it's not good because I have asked you to write it as a single power. Yes? So what I do, I know that if you are a little bit friend with numbers, 16 is 2 to the power of 4 multiply 2 to the power of 8, which is 2 to the power of 12. It's interesting. Without calculating at all, yes, without calculating these things at all, I guarantee that this number, whatever it is, you see this phrase is important. If you ask me, do you know this, how much this number is? I say no. But whatever this number is, they have to be equal because of these rules. So that is the power of rules in mathematics. So you can actually generate ideas. Yes? Yes, I will. Yes? But you might say, how did you understand to find this in this way? No way. This is experience. If you make this problem harder, I myself get stuck. And that is the beauty of mathematics, because if you are supposed to solve the same problem every day, it's not fun. Yes? But the challenge is coming from solving new problems to be excited. But I will explain it again. Do you have any questions? Yes?
Are you making it like, is this gonna be uploaded to YouTube?
Yes, these videos are always uploaded to YouTube. Yes. So here, let me describe it. Yes, do you have particular question?
Is this supposed to be 2 to the power of 4 or 2 to the power of 2?
2 to the power of 4, because that is 16.
Oh, okay.
Yes? Okay, let me describe that. You see, if before starting, I saw that, okay, I decided to make all of them related to 2 to power 8. How did I do that? Because I was thinking that, okay, because of exactly this, I realized that 24 is 3 to the power of 8, 8 is 2 to the power of 3, so this becomes somehow related to 2 power 8. Here I realize I can borrow 1, 2 from 6 and give it to here, and then it becomes 2 to power 8 again. And here I can take 1, 2 from here, still I have 2 to power 8, and this is already 2 to power 8. So I thought a little bit before teaching this to you, okay? And then I have my strategy now. By the way, this is extremely important. In mathematics, you should have a strategy. Otherwise, just randomly doing things, If you are extremely lucky, you will find the answer. But you shouldn't count on it because it's extremely rare. So you have to have a strategy. So my strategy is to write all of these expressions in the form of one single power. And I'm following that. So this is why I do not change it at all, because this is against my strategy. I want to keep everything 2 to the power of 8. This is already 2 to the power 8, so I don't bother to change it. But when I go to the next one, this is 2 to power 9. My strategy is to have 2 to power 8. So there's one way I can do that. How? Instead of 2 to power 9, I can write 5 times 2 times 2 power 8. Yes? Because my strategy is to make 2 to power 8 appears. And then 5 times 2 is 10. The same story here. 6 times 2 to power 7. This time I have a 1, 2 less. I need it. I realize, okay, that 2 is hidden in 6. So I realize to write 3 times 2. And then I have 2 to power 7. And then absorb this 2 on this. It becomes 3 to 2 power 8 again. Yes? So you see I am following a stretch. And then when I reach here, I saw that, God, I have 3 2's less. But then I realized 24 is 3 times 8, and 8 is 2 to power 3, which will make 2 to power 8 again. And then everything in terms of 2 to power 8. I have 6 of these numbers. I have 10 of them more. So far I have 16 of them. And then I have 3 more of them. It becomes 19 of them. Do you understand this part? And then 3 of them are gone. So I am left with 16 of these packages. Yes? And then, of course, this is a good progress. Even if I cannot continue, I made this good progress because 1, 2, 3, 4 terms. But I just reduce it to one single term. But here I can continue. Instead of 16, I can write 2 to the 4 and then multiply it by 2 to the 8. It becomes 2 to the power of 12. Yes? So if in this exam I give you this, the answer to this is 4096, I suppose. But if you write in the exam 4096, even though it is 100% correct, but you will get 0 points. Because the answer, the question is not asking you to evaluate that number. This is asking you to write it as a single power. Okay, that's also good to see how we can do this using GeoGebra. Now I want waiting for it. In the meanwhile, I will try to type this in GeoGebra so that we can save some time. Okay, so let me try to solve this one. I want to hear from you because mainly I saw that you are on the right track. That's a very good sign and encouraging for me as well because this shows that this is not for nothing. Okay, which one do you want to, what is your strategy? Because we have different powers of 3, which one you want to stick to?
To change all the exponents to 33 so that all of them are
Okay, so your strategy, I will follow yours, okay? So you want to change everything to 3 to power 33.
Yes.
Okay, you might have different strategies, but at the end we should get the same answer.
We can try like different
Okay,
strategies.
so let me just start here.
Shush, man.
Okay, I want to have your attention, please. Hello. Okay. So my strategy is to stick to this number. So here I have an extra 3 then. I have to take it out and put it here. So what's the answer? 9, 3 to the power of 33.
Yes.
Yes?
Yes.
And then I go here. Do I need to change anything?
No.
No, it's already according to my strategy. So what I do, I just write it down. Okay, do I need to change here? Yes. But I need to make it bigger. So this motivates me in my head to write this 3 times 3. And then lend one of these 3's to this one and keep 1 3 here. So this becomes plus. I keep 1 3 here. Then it becomes 3 to power 33 again. But 3 to power 34 is not according to my strategy. what do I write? I write 3 times 3 to the power 33. I don't need to change anything here. Yes?
How do you get 3 times 3?
Here,
Yes.
this is 3 to the power 34. My goal is to have 3 to the power 33. So I took one of them out. Yes? And then the last one. What should I write here? 2 to the, this one is 3 to the power 3. And I can absorb it here. No, 2 of them. I can write it as 9, 3 times 2, 3 to the power 2. Yes?
I wrote the question.
I will write it here. So this becomes plus 3 times 3 to the power of 30. Yes? Understandable for everyone?
Yes.
Okay, let me also double check my solution. So that is correct. I borrowed 1 3 to this one. I keep it the same. I gave 1 3 to this one. I borrowed 1 3 here. I keep it the same. I gave 2 3s here. Everything is okay. Now everything is written in terms of one quantity. So let us read. I have 9 of them minus 10 of them. So it means that I have minus 1 deficiency. I have minus 1 of them. Plus 3 more, I have 2 of them. Plus 3 more, I have 5 of them. Minus 5 of them, it is totally gone. So what is left is the last term. So the answer is 3 to the power of 33. And the answer is finally
3 to the power of 34.
I think only not so you also did that. So how many of you? What was your? Good.
Yeah. Okay, Baba, you know what I did?
Okay.
My question is actually correct. My answer is actually correct, but I just wrote the question.
Okay. So the people who made some mistakes, you have to take lessons. Otherwise, there is no teacher to be able to teach you this. After you learn what is happening, if you made some mistakes, you need to try to correct yourself. Okay, but let me just go to GeoGebra to see if GeoGebra is also capable of doing this for us. So what I do, I go to GeoGebra. I already put this number there. I don't know. Okay, so this is the answer. And that is reasonable because this is 3 to the power 34. It should be a big number. Okay, but this is useless. What we want to do, we want to factorize this. Yes, factor. Yeah, we want to factor this number, and that is number 4. Let me see if this calculates this one. Yes. So 3 to the power of 34. So what we have done is completely correct and according to this calculation. Okay, I will pause, stop here. You can work a little bit on your own for 20 minutes. But what we want to do next time, I will continue the rules. Let me finish this sentence. You see that without the rules, I was not be able to do this.
Yes.
So I want you to know that this is not just something that can solve trivial things. It can also empowers us to be able to solve something that is not trivial. So it is extremely important in mathematics to learn the rules properly. Okay, I will update the Google Classroom in a few minutes so that you know where to work and what to do. You can start already with what I had written before. Thank you very much.